Next up, we have James Carpenter from ESA, who will be talking to us about the prospect payload. Take it away, James.
That's great. Thank you very much. So I'm presenting on behalf of the project scientist for Prospect, David Heather, who's currently in an aeroplane somewhere over Europe. So I'll do my best to present his slides. Next slide, please. Okay, so I want to talk about Prospect, which is a package which is in development in ESA. And we envisaged some years ago that there would come a time in the early 2020s when there was really an international effort to explore and understand the lunar poles and to understand the distribution of water ice and other volatiles, both for science and for exploration. And so we started developing Prospect with that in mind to perform an assessment of the volatile inventory in the near surface regolith. And in contrary to Viper, which is really a mobile platform, we would try to understand from a stationary platform where we didn't have mobility, how can we get the most out of measurements that we would make there? So currently Prospect is in phase CD development for Russia's Lunar 27 mission, which is planned for launch in 2025. And we're also very excited to be discussing with NASA at the moment about the possibility to fly Prospect as part of a future joint NASA-ESA polar delivery. Next slide, please. So in this slide, you'll see basically the list of the objectives that Prospect is designed to address. The ones highlighted in blue are all specific to volatiles, understanding their inventory, their locations, their abundance, their isotopes, where they're from, looking both at chemisorbed and physisorbed volatiles. Also, it's worth noting, based on one of the earlier presentations, some of these are also looking at the possibility that there's organics present, and can we identify whether there's organics present. I won't go into these in details now, but I'll give you a highlight of some of the key ones in the next slide, please. So what we're going to do is we want to drill down to depths of 1 meter at very low temperatures. You want to characterize the environment at those depths and then extract volatiles and determine the abundance, the composition, including the isotopics, and the origins of the volatiles that we find there, both cold trap volatiles and chemisorbed volatiles. And we're also able to perform some investigations into some ISRU processes. It's a little bit of an adjunct to the volatiles question, but the laboratory is also able to do some experiments along those lines, and I'll tell you something more about that in a moment. Next slide, please. So this is an illustration of Prospect. We have a drill. The drill drills down to up to 1 meter. We extract samples. So we take 2 samples, a larger sample, which is then delivered to the Russian instruments on Lunar 27, and a 100 milligram sample, which we use for the PROSPER analysis. And PROSPER is our analytical laboratory. Whilst drilling and downhole, we measure the torque that's associated with drilling to give us geotechnical information. We also measure the temperature in the subsurface and the electrical permittivity at the depths where we're drilling.
A few minutes left.
We look at the surface while we're drilling. Samples are then deposited into a solid inlet system where they're sealed and heated after being imaged. The heated samples then involve gases, and the gases pass into our laboratory. We have an ion trap mass spectrometer provide a broad suite chemical analysis, and then a gas processing system which allow us to separate and process those gases to make them suitable for isotopic measurements in our magnetic sector mass spec, where we can look at hydrogen, carbon, nitrogen, oxygen, and noble gas isotopes at around the per mil sort of level. Next slide, please. So we have a science team where we have certain investigations going on. So we have investigations into the drilling and geotechnics and the sample handling, into the imaging and modeling and the spectral analysis of the surface. We have investigations into noble gases and light elements and their isotopes, and into the thermal environment and what's needed to preserve volatiles in that environment, something which is really a challenging thing to do and something which will be very important for later missions too, including sample return. And we also have investigations looking at the precursor experiments for space resource utilization and for prospecting, and investigations into the permittivity in the subsurface. Next slide, please. And so during the phase CD, we have some very
30 seconds
that are ongoing investigations, looking at the volatile preservation, looking at the characterization, and this is really key thing actually, is understanding the magnitude and the impact of all the different vectors of potential contamination of the volatile samples that we're going to measure, whether those are locally produced on the lander on the moon or whether they're introduced during the development and the build. We're also trying to prioritize the prospect operations to make sure we get the maximum science out in the early phase of the mission, especially.
That's time.
And with that, I'm done. Just to indicate on the right-hand side, there's some interesting plot from the water release experiment looking at hydrogen reduction of samples. In this case, ilmenite, but the paper can tell you more. I'm done. Thank you.